So we'll start this lesson by talking about the computing model. Then we'll move on to talking about different types of programming languages, and that'll lead us to our first C++ program, which is called Hello World. So the purpose of this course is to teach you programming, and programs, of course, solve problems. Programs also consist of a sequence of instructions to do something. Programs run on computers, so it's important to understand parts of the computer at a high level. Uh, so we will talk about computing in the following high level parts. The first one, of course, is CPU that does the logic and computation. Then there are a couple of different types of memory. There is faster memory or RAM that is used by the CPU to do computation. There is secondary storage or larger memory that is used to store larger files or databases. There are input devices, for example, your keyboard or your mouse or the touchscreen. There are output devices, which are your display, your monitor, might be your printer, and other kind of display devices. There's, of course, communication, such as Wi-Fi and Bluetooth. So this diagram basically models that out. Now, having a basic understanding of these things helps understand the performance of your program. How you write your program affects its speed, its memory efficiency, etc. Once a program gets more complicated and gets beyond the capacity of your CPU and RAM, you will need to optimize it, and understanding the computing model will help with that. Additionally, in talking to file systems and talking to the network has additional performance penalties that we have to optimize for in our program. Now let's talk about programming languages. At a very high level, we split them up into three different categories depending on complexity. The first one is high level languages. These languages are things like Python and C and C++, and that are meant to be used by humans. Then that is what we will use in this course. Some of these languages need to be converted into a lower level format called assembly language before they can be run. Assembly code looks like this. It's still humanly readable, and if you know these instructions, you can kind of tell what they're doing. For example, here we're comparing a register to a value, we're jumping to another line. In this case, is jumping to this tag done, and so on. Finally, even assembly languages need to be further converted into machine code before they can be run on a computer. You can think of machine code as basically ones and zeros. Now, further, high level languages are split into two categories. They are compiled languages, and then there are interpreted languages. C, C++, Java, these are all compiled languages. They need to be compiled by a program called a compiler and be converted into assembly languages and then further optimized into machine code before they can be run on a computer. The other category, interpreted languages, these are examples are Python or JavaScript or Ruby. They can be run without being compiled. They can be run straight away by another program called the interpreter, right? So the question is, why do you have these two different categories? Now, there are trade-offs to each. Compiled languages, since they're optimized by the compiler, tend to be faster, right? Interpreted languages, on the other hand, are easier to program in because you don't have to wait for a long compilation process before you can start using your program. Now, C++ happens to be a great first programming language to learn because if you learn it, everything else, all the other languages, become fairly easy.